Welcome to Get Your FRQ On. This question is from 2014. It's question 3, and it is not calculator active. In the question stem, we have a function defined as a graph. It's just 3 line segments, and a relationship between f and g. In part A of the question, we are asked to find g of 3. And given the way that g is defined, we can calculate g of 3 by calculating an associated integral. G of x is defined as an integral involving the function f, which is the graph provided. So if we just set up the integral, g of 3 would be the integral from -3 to 3 of f of t dt. It's all line segments, so it's really just finding some areas of either rectangles or triangles, and if we do that and add up the different areas, we get 9. In part B, we are asked to determine open intervals on the interval from -5 to 4 for which g is both increasing and concave down, and to provide a reason. So given the way that the function g is defined, g will be increasing when g prime of x is positive and g prime of x is f of x. So really we just need to know when f of x is positive. Based on the graph, this will happen when x is between -5 and 2. And g of x will be concave down whenever g double prime of x is less than 0. And since g double prime is equal to f prime of x, we just need to know when f prime of x will be negative. This happens on a couple of different intervals. This will be when x is between -5 and -3, and when x is between 0 and 4. So if we combine those two intervals, g of x will be both increasing and concave down on the intervals from -5 to -3 and from 0 to 2. In part C of this question, we are defining a function h to be g of x divided by 5x, and then we are asked to find h prime of 3. Since h is defined as a quotient, we can apply the quotient rule to come up with a generic rule for h prime of x. So if we do that, h prime of x will be 5x times g prime of x minus 5 times g of x, all over 5x quantity squared. And so if I want to find h prime of 3, I can just substitute 3's into everything. We get 15 times g prime of 3 minus 5 times g of 3, all over 15 squared. Since g prime of 3 is really just the same as f of 3, we can read f of 3 from the graph. We can read g of 3 by calculating the integral. Remember, we did that in part A. That's 5 times 9, that's going to be 45. And then after this, you can simplify whatever you need, but the answer is -1/3. In part D, we are defining another function p of x to be f of x squared minus x, and we are asked to find the slope of the tangent line to p of x at the point where x is equal to -1. All right, so notice that this is an application of the chain rule. P prime of x will be f prime of x squared minus x times 2x minus 1, and therefore p prime of x would just be f prime of x squared minus x times 2x minus 1 when x is equal to -1. So p prime at -1 is going to be f prime at 2 times -3. F prime at 2 you can calculate from the graph. That's -2. -2 times -3 is 6. So the slope of that tangent line would be 6. And that's it for that question. Don't forget to like it and subscribe for more free response question solutions. Have a good day.